Robert Oppenheimer, one of the 20th century's most influential physicists, was born on April 22, 1904, in New York City. This documentary, Part 1, delves into his formative years, exploring his early life, comprehensive education, and the scientific foundations that shaped his extraordinary career. We trace his journey from a privileged upbringing to becoming a pivotal figure in theoretical physics. Born Julius Robert Oppenheimer, his parents were Julius Oppenheimer, a successful German-Jewish textile importer, and Ella Friedman, a painter whose family had deep roots in New York. The family enjoyed a privileged upbringing in a Manhattan apartment adorned with fine art, fostering an environment of intellectual curiosity. Oppenheimer's intellectual prowess was evident from a young age. He attended the Ethical Culture Society School from 1911 to 1921, a progressive institution emphasizing ethics, social justice, and secular humanism. At the Ethical Culture School, Oppenheimer excelled across various subjects, including English and French literature, and developed a particular interest in mineralogy. His advanced intellect allowed him to skip several grades. His early correspondence with the New York Mineralogical Club was so sophisticated that he was invited to lecture, unaware that he was only 12 years old, showcasing his remarkable precocity. After graduating as valedictorian in 1921, his further education was briefly delayed by an attack of colitis. During his recuperation in New Mexico, he developed a lifelong love for horseback riding and the American Southwest. In 1922, at the age of 18, Oppenheimer enrolled at Harvard University. He initially majored in chemistry but quickly discovered his true passion in physics, pursuing a wide range of subjects. His independent study and academic excellence allowed him to achieve graduate standing in physics during his first year, culminating in his graduation summa cum laude in just 3 years in 1925. Following Harvard, Oppenheimer continued his studies in Europe, a pivotal center for advancements in quantum mechanics. In 1925, he went to the Cavendish Laboratory at the University of Cambridge. Working under J.J. Thomson, Oppenheimer found experimental work challenging, recognizing his talent lay in theoretical physics rather than routine laboratory tasks. In 1926, he accepted an invitation from Max Born to study at the University of Göttingen in Germany, a leading global center for theoretical physics. There, he immersed himself in the groundbreaking work of quantum mechanics pioneers like Werner Heisenberg, Wolfgang Pauli, and Niels Bohr. He received his PhD in physics in March 1927 at the age of 23 under Born's supervision, making significant contributions to nascent quantum theory. Notably, he collaborated with Born on the Born-Oppenheimer approximation, a fundamental concept for molecular wave functions that separates nuclear motion from electronic motion. After his doctoral studies, Oppenheimer returned to the United States, holding the United States National Research Council Fellowship at the California Institute of Technology in 1927. In 1929, he accepted faculty positions at both Caltech and the University of California, Berkeley, dividing his time between the two institutions and becoming a full professor at Berkeley in 1936. During this period, he became a central figure in theoretical physics, attracting brilliant young students and effectively establishing a leading school of theoretical physics in the U.S. His early research at Caltech and Berkeley focused on quantum theory and theoretical astronomy. He made significant contributions to quantum electrodynamics, predicting the existence of the positron in 1930. He also collaborated with Nobel Prize-winning experimental physicist Ernest Lawrence, assisting in the interpretation of data from the cyclotron, a particle accelerator. Oppenheimer's work extended to stellar models and the theoretical understanding of celestial phenomena, making major contributions to the theory of cosmic ray showers, neutron stars, and black holes. Notably, in 1939, he co-authored a pioneering paper with his student Hartland Snyder on continued gravitational contraction, which utilized Einstein's general relativity equations. This work explained how stars could collapse into what we now call black holes, establishing the Tolman-Oppenheimer-Fokoff limit for neutron stars, a model still considered significant today. Oppenheimer's early path, marked by intellectual curiosity and groundbreaking theoretical contributions, meticulously laid the groundwork for his later monumental contributions to science and history. In Part 2 of our documentary, we delve deeply into the profound and multifaceted impact of J. Robert Oppenheimer, carefully examining his pivotal leadership within the massive Manhattan Project, his absolutely critical wartime contributions that helped shape the outcome of World War II, and his equally significant post-war influence on national policy and scientific direction. We will also thoroughly explore the lasting and enduring legacy that he left on the worlds of science and global policy, fundamentally shaping the course of the 20th century and influencing developments well into the future. Oppenheimer's major and defining role in the Manhattan Project truly began in 1942, when he was directly recruited by the project's military leader, General Leslie Groves, to spearhead the scientific aspects of this unprecedented endeavor. Shortly thereafter, he was formally appointed as the scientific director of the Los Alamos laboratory located in New Mexico, a crucial position that he held steadfastly from 1943 through to 1945. Under Oppenheimer's visionary and steady leadership, the Los Alamos site rapidly transformed into the central and indispensable hub for the top-secret development of the atomic bomb, coordinating efforts across multiple disciplines. Oppenheimer personally oversaw a vast and diverse team comprising over 6,000 dedicated personnel, which notably included many of the era's most brilliant and renowned scientific minds from around the world. His own deep expertise proved absolutely crucial in significantly advancing key areas of theoretical physics, particularly the highly complex and intricate domains of implosion dynamics and the processes of nuclear fission. These critical scientific developments under his guidance were absolutely fundamental to both the innovative design and the actual physical construction of the world's first atomic weapons. The dramatic culmination of these intensive and collaborative efforts came with the Trinity test, which was successfully conducted on July 16, 1945, in the remote area of Alamogordo, New Mexico. This historic event marked the world's very first detonation of a nuclear weapon, representing a moment that irrevocably and forever altered the entire trajectory of human history and warfare. In the immediate aftermath of this successful test, atomic bombs were swiftly deployed against the Japanese cities of Hiroshima and Nagasaki in August 1945, actions that directly contributed to bringing World War II to a rapid conclusion. Transitioning into the post-war era, Oppenheimer continued to exert his significant and respected influence, notably serving as a key advisor to the newly established Atomic Energy Commission, known as the AEC, from 1946 all the way through to 1952. Throughout this important period, he strongly and passionately advocated for the international control and cooperative management of nuclear energy, firmly believing that such measures were absolutely essential for achieving and maintaining global peace and security. However, his forward-thinking views frequently put him at odds with various political and military factions within the government, ultimately leading to significant personal and professional challenges later in his career. A truly pivotal and defining moment in his life arrived in 1954 with the highly publicized AEC security hearing, a contentious proceeding which ultimately resulted in the suspension of his long-held security clearance. Despite this major professional setback, Oppenheimer persevered and continued his vital intellectual pursuits, serving faithfully as the director of the prestigious Institute for Advanced Study in Princeton, New Jersey, from 1947 to 1966. At this renowned institution, he actively fostered an environment rich in intellectual freedom and rigorous scientific inquiry, profoundly influencing and mentoring a new generation of promising physicists. Then, in 1963, as a notable gesture of political rehabilitation and recognition, he was awarded the highly prestigious Fermi Award, which stands as the nation's highest honor in the field of nuclear science. J. Robert Oppenheimer ultimately passed away on January 18, 1967, leaving behind a complex, controversial, yet undeniably enduring legacy in both science and society. Today, he is widely remembered not only for his instrumental leadership in the creation of the atomic bomb, but also for his profound and lasting contributions to the fields of quantum theory and atomic science. Indeed, his extraordinary life serves as a powerful testament to the profound ethical dilemmas and far-reaching societal implications that are inherently tied to major scientific advancements.